isn't going to live up to the last one. And actually, we have one of the authors and founders with Jay Krebs here, the inaugural one, and we had cake. Good news is they set the bar so high I don't have to duck to get under it. I can walk clearly underneath that. So, all right, let's get started then. All right, thanks to our sponsors, right? Conversing, Cloudera, and Confluent. Someone already overheard someone asking about if there's a national conference. Yes, the Kafka Summit was 6-8 weeks ago, and all the recordings are online. All right, so anyway, this is the Confluent slide, right? Developer courses, developer and operation courses are available. The Chicago classes are September 6th and 7th. And you can get $100 off training using the Chicago Meetup code.
And we'll, we're videotaping right now, and we'll make the slide deck available on the blog as well, right? You're okay
Sure,
with that?
yeah.
So you can get a copy of this if you want to get it.
No, I assume every meetup does. But anyway, all right, so.
Wow.
I think I hit a speed button. I didn't realize on here. All right, so we're conversing, right? We're working the ad tech industry, ad serving, real-time bidding. I try to group several different descriptions together, right? We maintain ongoing real connections with millions of consumers delivering personalized media across a broad range of platforms, devices, and advertising solutions. All right, so I'm a manager of a data Hadoop team. There are 7 of us currently. Are basically Flume, Kafka, MapReduce, Hive, whatever we need to, manage the data pipelines. So, all right. So our agenda, an overview, an impetus for Kafka, why we introduced it into our data pipeline, an overview of our pipeline, a simple Flume and Kafka overview just to kind of get an idea of the differences. But I guess I'll stop right here. How many people are currently using Kafka? All right. How many people are currently using Flume? How many people using Flume have a problem going to HDFS sometimes? That's good. All right. So both Flume and Kafka I should say, Flume's very extensible, and some of the libraries we're using from Kafka are very extensible. I'll talk about what we've done to get more performance and fit our business case. Other things we've done with Kafka besides that, what we plan to do next, and a little overview, or at least a slide on if you want to get started with this kind of a hello world way to stand yourself up and get going. All right, so our data, just in the ad tech industry, right? You get requests from different exchanges. So those would be bid requests, and they fall into 2 categories: requests from exchanges. Do we want to buy this advertising space that we actually bid on, and ones that we pass on, right? And our volumes are 6 to 7. We actually hit 9.5 billion the other day. We don't bid on anywhere between 75 and 85 billion requests a day. Each one of these ends up becoming a log record, an event that we log through Flume and Kafka. We have another group we call critical logs. So these are the ones that, billing related, pacing related, new users, performance monitoring, things that you really want to keep a close eye on. You look at the bid requests. This is more analytical. If it's a little delayed, you're okay. And there's another group that we actually named the topic in Flume channels. They go under other, because I'm real creative at names, right? So any other kind of unclassified analytics measurement. And then we have, Conversing has grown through a lot of acquisitions. We have other divisions that have TSV data, and we Flume those and bring them into the same pipeline. Okay, so pre-Kafka, what we were doing, right? We had our servers that are handling the ad tech interface, right? They were using an embedded Flume agent. They send to a local data center Flume agent that compresses the data, sends it to our Chicago data center, which we then write to a dedicated Hadoop cluster. All of our data was when we went to the Flume architecture, everything went from TSV to Arrow. We were Fluming Arrow objects. At this point, this era, we went between 50 and 80 billion Arrow objects per day. It's a 3-hop, Flume pipeline, 1, 2, 3, and then into Hadoop. And all was well until we had a shared cluster. We went from a dedicated cluster to a shared cluster. At which point, Flume does not have a interface into any way of looking into a resource queue, right? It doesn't really work well with a name node or any kind of resource management. The name node became overwhelmed. We were having lots of problems fluming data, data loss, data recovery, a lot of downtime that you were supposed to be doing some other kind of development work. So we needed something to solve this. Turns out what we needed was a buffer. Kafka was that buffer. So an overview of what our architecture looks like. We have 3 data centers, one on the West Coast, one on the East Coast, and one in Europe. And these are ad tech facing data centers. And then we have our Chicago data center, which is all our processing and data warehousing. So as an example, we kind of step through how this works, right? If you were to take in our East Coast data center, we have about 800 servers that are fluming to us. They are all using an embedded Flume agent. There's an exception to that I'll mention later. Those all send the data to a collection of data pipeline servers. These are all currently running Flume and Flume alone. The whole idea here is to get the data off the ad stack. They don't have the disk capacity, they're meant to be serving the ad tech. And then get the compression. You don't want to do it on your production servers either. So we compress the data here. The data is then forwarded onto a cluster of 30 Flume and Kafka servers in our Chicago data center. There's 2 JVMs running on each of these boxes. One is a Kafka broker, one is a Flume agent. All right. So initially, in the phrase I was referring to earlier, we were doing 50 to 80 billion. We just had a Flume agent running on there, but run directly to HDFS. All right, and then getting it out of Kafka. All right, we have a Hadoop Enterprise Data Store or Enterprise Data Warehouse. I've kind of stolen slides from different decks, so you'll see that I'll say Hadoop Enterprise Data Store and Enterprise Data Warehouse. They mean the same thing. I just didn't clean up all the slides to say the same thing. All right, so here, to get the data out of Kafka and into HDFS, we use the Camus library, which was developed at LinkedIn. It's part of the LinkedIn and Confluent open source platform still available. All right, so a little background, just in case keep you familiar with terminology I might throw out that's common in the office, right? Our enterprise data store partitioning, right? This is really high partitioning, and what we're doing here is, if you look at the directory structure, right? Bid log, so this is going to represent the table name we're going to use in Hive, right? And then we have these subdirectories, the starting date, right, of say May 29th and an ending date of June 4th. So this would be a Sunday to Saturday week, right? And identified equals 1. This means we bid on a opportunity where we knew who the user was we're bidding. So at this point we really have a ad, a client that we're already targeting for. And then a source, which we'll cover that in a second actually. So going to the topics now. Bid log, that's the table name, what kind of event was being logged, the starting date to ending date, Sunday through Saturday inclusive weeks. Identified, yes, we knew who this was. If it was equal to 0, that would mean we were bidding on somebody we didn't know. Source browser, so this would be your regular PC, your browser, Netscape, Safari. I'm just giving away my name.
IE6.
I never was an IE. Okay, so when you look at this, how many people are using Hive actively? Okay, so when you're using when you map this to Hive, right? You do a create table. You'll notice that we have these partitions defined the same way: start date, end date, identified, and source, right? The thing that is kind of non-intuitive, particularly to non-technical people that just write a little SQL in a construct, right? Is that actually is part of what you can access through SQL, right? So if I were to write a query now in Hive, right, I can specify the source and the start date, right? And I can put my where condition, the start date, the end date, and I can group by it. But if you notice, those aren't even columns in the table. All right, so it's going to map that to the file system. And the real advantage here is, if you're organizing your data this way, the MapReduce or Spark job that runs to get the results of this is going to do a glob pattern on the file system and only go through the files matching that. So it greatly reduces your input to your MapReduce or Spark job behind Hive. All right, so a little Flume overview here. Let's a little blue dot represent a batch of, say, 1,000 Flume events coming down. All right, in this case, our ad server uses the embedded Flume agent, and so I didn't fully finish this slide. Sorry, let me take one step back. These boxes represent a Flume agent, right? A Flume flow is a collection of Flume agents from a start to final resting place. In our architecture, our ad server uses an embedded Flume agent, which actually doesn't have a source. So when our ad server logs an event, it puts it directly on a channel. That's the unit, that's the persistent layer within a Flume agent. All right, so when it goes on the channel, right, we put it on, it's on the channel, and then a transaction is started. When that transaction starts, the data goes to the next Flume agent, right? When it gets down to the next Flume agent, there's an acknowledgement sent back. If this was a batch of 1,000 and it acknowledges I got all 1,000, it's deleted now from your channel. Their transaction is completed and committed. If it does not get all 1,000, it's possible it can get a partial batch. Those will be committed and they will go on they will continue through your flow, but the lack of acknowledgement back that got all 1,000 means all 1,000 will be sent again. So Flume, while it guarantees delivery, it does not guarantee delivering one semantics. All right, so now you get to the interceptor. An interceptor allows you to modify the data in flight. Right? So in our case, right, we change it to green and then it moves to a selector. What a selector does is it lets you specify what channels it's going to go to in the next step. In this case, what we're saying is, hey, we can send it on one or more channels, or we can throw it away if we want. So in this case, if we want to send it to 2 different destinations, so in this case, this would sync maybe to one Hadoop cluster, this might sync to a different cluster, or HBase, or Kafka, or whatever. What I'm trying to demonstrate here is that for Flume to make a second copy, it has physically made 2 copies of the data in the Flume agent. So in this case, we're doing 14 terabytes of data a day. If we're going to send it through Flume to more than one destination, we're going to go 14, 28, right? Do the math, 42 terabytes a day going through the Flume agents. All right, and then ultimately it syncs and it lands in its destination. So that's a high-level Flume overview. And the point I'm really trying to make here is it's 1 copy per consumer, right? So the more consumers you have, the more IO you're having on your Flume servers. So let's take a look at Kafka simplified. All right, Kafka is it's a temporal queue, right? In which you have, in this example, we're keeping data for 10 hours, right? In order to get data in a Kafka topic, right, you use the producer. The producer basically is doing a push onto a queue. And when it comes in, everything gets pushed in at hour 0. And as time passes, it ages down, and once it hits hour 10, if that's what your TTL is set to, it falls off the end, and you have that long of a lifespan within your copy. So now, what's our consumer? We use a library, like I said earlier, from LinkedIn called Camus. This is the author, Camus, that LinkedIn happened to name this product off of. All right, so by default, when you run Camus and you give it a topic to pull data and write the HDFS, it says, I'm going to start at the beginning of the topic. So if it's 10 hours, the first time you run, it is going to read from the start of the topic all the way to the end. And when it's done, it is going to have a little, it's going to remember, hey, the last offset in this topic that I read was 10,010, right? So now, 3 hours passed, right? And now we've got 3 more hours worth of data. I'm representing 1 Kafka message per hour. We do a little more than that, right? But as you can see, the first 3 hours have fallen off the end. And if you look at this as a timeline, our Camus index into 1 offset is now 3D. So if I run another Camus job to pull data to write it to HDFS, it's going to advance, read those 3 records, update its offset. Camus does all the bookkeeping for you, so you know where you last left off, and it will pull the data, and you can put in a scheduler, like, hey, if I want to pull my data every 15 minutes, you set up a scheduler job, every 15 minutes pull data, you're going to have 15-minute chunks. That's as real time as your data will be pulled into HDFS. All right, so what's nice, one of the big advantages out of Kafka here is that it's 1 copy. You can have as many consumers reading as you want. In this case, right, you can have Spark job, you can have Flink, you can have Storm, all reading. They all they have to do is have their own bookkeeping as to where they last left off so they know where to continue. 1 copy, multiple consumers. Pretty much limited by your IOPS and your network, right? All right, so now going to go over some of the customizations we made in building out our data pipeline. I'll start from the top, the ad servers, serving up the ads and taking the bid requests. So the first thing is, when we were evaluating Flume, it didn't perform like we hoped, right? And the number of events that were being sent, or Flume events, Flume bundled objects, was going really high, and it looked like it was not going to pan out. It would be hardware prohibitive for what we would gain from it. But as we dug into it deeper, we found that it's really the number of events, not the size of events, right? So if we go and we were to take one Flume event, and a Flume event is in itself an Avro object. It is an Avro schema that has two fields: a header, which is a map, and a body that's a byte array. If we were to say, all right, well, let's not put one object in the body, let's put a collection of objects. In our case, an Avro data file. So we put, and this is just simulated here, you can see there's 3 more Avro objects, a little mini Avro data file. We will put as many as 600 Avro objects in an Avro data file in the body of a single Flume event. One thing to note here is next points, right? So what defines the contents of our body? Well, we will close a Flume event and write it after a time interval, right? So we don't want this data backing up on servers that are doing millions of transactions a second. So a lot of ours flush every second at longest. So even if they have a maximum number of events of 600, if a second gets, send it. The other, so we flush on a time interval, or a number of events, or on the change of minute. What that guarantees us, right, is that the minute, the timestamp that's on the header, so the Flume event, kind of the wrapper object, is of the minute that all the data is in. So you will never see data in here that is not from the 59th minute of the 23rd hour of May 23rd.
Why do you do that? Because of staleness? Because
I'll get to that.
Okay.
I will get to that. So, okay. The other change that found kind of surprising, right, is that Flume has a couple ways of monitoring. You can do it through JMX, and you can do it through HTTP. The embedded Flume agent does not have monitoring in it, which seemed kind of silly if you wanted to keep an eye on how things are going and you've got it built in your ad stack. So this is actually a really simple cut and paste that, if I wasn't so lazy, maybe I would have tried to contribute this back to Apache or something, because I don't know, it just surprised me they left it off. It's very easy to add. As I said, we send everything as Avro objects. So our whole infrastructure was built out around Avro. And when the requirement came that we needed to collect data from other divisions of the company that, like I said, Conversant is a conglomerate of acquisitions, right? They all had TSV data. And in addition to TSV data, their software was all written in C and C++, which didn't have a Flume client to it, right? But Flume comes with the spooling agent, which will basically monitor a directory, read the data in, put it in a Flume event, and send it on. But then we would have to handle our pulling out of Kafka 2 different data types. We'd have to pull out TSV in some cases, we'd be pulling out an Avro. Instead, we extended the spooling agent to do a TSV to Avro translation, and it actually bundles it up into a number of objects and sends out a Flume event with 50 Avro objects in the payload, sends them all. So now when we're handling everything downstream, all looks the same. There's no customization for any other data types. All right, so now in our local data center, this is where we do all the compressing. Not a whole lot of customization needed to be done here. One thing I found in evaluating Flume was that compression is expensive. I don't think that's any big revelation to anybody here, except it didn't really parallelize in Flume like I expected it to. And even some of the documentation, either I didn't understand it or it was gravely misleading in that it would parallelize. So what I needed to do was basically split this apart into multiple channels to parallelize it myself. And I'll give a slight example of that coming up. How I split it up into multiple channels was with the custom selector. And that would evenly distribute the all load, an even amount across every channel. This was also useful in migrating off dedicated cluster. I'll explain that some when I have a little visual up for that. And the other customization we made was a key value filter. We had a kind of a requirement where we were generating events for more than we needed. We only needed a subset of them, and they could be identified by a key value pair. So they asked us how quickly can you filter this out because we're accidentally hammering too much data, so we put in a key value filter that would, on flight, inspect the data, throw out records that we didn't need to keep. All right, so now on our Chicago data center, so this is where we're syncing initially straight to HDFS and now to Kafka, right? On the Kafka side, because our data was coming from different sources and we wanted to have a key in our Kafka messages that was consistently represented, we wrote a custom interceptor to inspect the data and set a key value that would be used in the Kafka message consistently based on any incoming data type, coming from any division. All right. We had a custom selector which would allow us to direct data, and particularly what was really valuable here is I mentioned that we have those critical ones, right? That the critical log group, these are our things that are really important for billing, reporting, monitoring, right? This allowed us to be able to segregate out by importance of the logs, the metrics, where they were. And if you were behind on the high volume, right, we're doing 75 to 85 billion bid requests that we log but didn't actually deliver on a day. If we're behind on those, nobody's going to kill except the data warehousing guys. And I mean, who in here cares about the data warehousing guys? The billable stuff that's monitoring, that's on all the web applications for monitoring, those people notice right away. So then, Flume, when 1.6 came out a little over a year ago, it introduced a Kafka sync, a Kafka channel, and a Kafka source. But this was, when we first looked at this, and we also looked at the Camus library, the Camus library is actually written expecting all your data to be Avro objects. And I thought, hey, we're already doing Avro. Oh, this should be great. So first thing I did is I took the sync that the Kafka sync that comes with Flume 1.6 and said, all I have to do now is take my Avro data file, iterate over all the objects in the list, and put those on as Kafka messages, right? It'd be great. And then I'm going to use Camus verbatim. I don't have to do anything. It's right out of the box. There's no customization of Camus. Unfortunately, with our hardware, we were producing so many Kafka messages that at 10%, we were really maxing out our hardware, right? This was the same reason that we bundled them all up in Flume, was that the hardware we had was not able to keep up if we didn't make bigger packages. It was almost it took the same time to send 1 million Flume events one at a time as to send 10 million grouped in bundles of 10, right? So, or blog objects, I should say. So anyway, the first thing we did when we looked at Camus was we said, hey, we want Camus and Kafka. We're like, oh, Camus, minimum amount of changing is we just take these out of the list and put them in, but you really crushed it. So then reverse that, and instead, what we're putting into Kafka is the Avro data file that headers with the byte array of Avro data file. Alright, so H-based check input. I mentioned earlier that Flume will duplicate, right? And the convention seems to be on, when reading the material out there, oh, you just run a MapReduce job to remove your duplicates. Well, how far back do you need to go, right? How backed up were you? If you're backed up more than a day, and you're doing 100 billion lines a day, what's a MapReduce job to remove duplicates over 100 billion lines? What if it's 2 days, right? So that really wasn't an acceptable solution, and duplicates wasn't an acceptable solution because we'd already kind of guaranteed we weren't going to have duplicates. So if you look, let's see here, I guess I got to go back a little. Would have been good to have it in this slide. If you look here, you'll notice that we're putting a UUID, right? This Flume event is an atomic object. You'll either get the entire Flume event or you'll get none of it. But we put a UUID on here, right? So what this does is it says, hey, if I've got 600 in here, there's one ID to let you know what it is. And we put it into HBase when we get it. And so before we put into Kafka, we check HBase. Have I seen this UUID? If I haven't seen it, I put it to Kafka and I put it to HBase. So now it's there. If there was a duplicate, the second time it comes in, it says, have I seen this UUID? Yes, throw it away. Very simple logic. We haven't actually ever had a verified duplicate come through. Not that everyone's looking all the time. And it isn't foolproof, right? You've got the parallelization. It is, however small, it is possible, right, that 2 parallel Flume agents would be processing a copy of the exact same Flume event at the same time, right? You get a miss, and then you both put, you have a duplicate. All right. So, so the HBase check. All right, next topic. So Camus is the library, right, for pulling data out of HDFS. one of the, there's three interfaces that we had to implement here. And one was the partitioner. So the partitioner is what's doing the logic where I demonstrated earlier with the partition, right? Here's your log type, and here's your start date folder, your end date folder, right? It comes with the partitioner, but we had demands beyond it. And I actually gave an example of how we're partitioning it, right? But the included partitioners didn't exist. So this goes back to your question of why do we bundle these up this time? The partitioner is working at this level as a whole, right? So if we want to be able to put data in, when it pulls off and decides what folder, it's looking at this timestamp to determine what folder to put out. So if we didn't flush on the minute, and this data file had the first half of the records from the 23rd, and the bottom half were from the 24th, all of this data would go into a folder on HDFS of the 24th. So now when you run your query and you specify your partition, right, you're going to miss the records that are on the 23rd. But if you were to run a query over everything and include every partition, you'd get different results. It's misleading. So this is definitely a con of how we bundled it up. It hasn't hurt us badly. The other reason why bundling it like this can be a little bit painful is you'll find if you're, especially in the Flume community, and I think we'll learn more as we get deeper and deeper into the Kafka community, is that there are utilities that are out there pre-developed that you might need to use, but they assume that your body has one event in them. They're meant to operate on one event. So if you want to reuse one of those, right, it's take the open source and extend it to say, I don't need to go on one event, I need to now put a wrapper around it to iterate over the whole collection and do that operation on all of them. All right, so in order for the partitioner to work, there's a decoder interface, which is really simple. It needs, basically what it needs to tell you is what field to get. And so we basically take out of our, we can basically say, when someone asks on the decoder whatever the timestamp is, we say, well, call the get timestamp method, right? And then there's also one to find out what the name of the actual log type is. And that's very simple, trivial customization. The big customization here was Camus is meant to work on Avro. So if you have Avro objects in your Kafka messages, it will write to HDFS in an Avro data file. As our data warehousing team had done some evaluations of columnar data store, and it had huge compression improvements, and going to columnar, it was decided we really need to go to columnar and HDFS instead of Avro, and we had to invent that solution. So what we did is we took the existing provider that was Avro and extended it, right? So now it reads in Avro and it writes columnar data format. All right, so in short, what's our pipeline look like now? The ad server stack, the embedded Flume agent, going to a compressor agent, going to a landing agent. Now these are physically the same box, right, of Kafka striped across all 30 of them. And this Flume agent basically puts it right on a Kafka topic, which can then go into our enterprise data store. All right, that's what I just said. The point to mention here with the buffer regulate, right, is when this Camus job, the red arrow is running, right, it's a MapReduce job. So it's fully integrated with Yarn, it runs in its own queue, right, so it has resources. Unlike Flume that was trying to write to a cluster with no guarantee of resource and dying, and if the job fails, everything rolls back, you run it again. Your Camus index, when it fails, it knows, and it doesn't advance the index, so you can just run the job again when you have more resources. Okay, and this MapReduce framework to land the data, all right. Flume pros and cons. Bifurcation requires a full copy, right? Which, as we've grown and more people want their own copy of the data to play with, that becomes more and more expensive, right? And this is trying to demonstrate or show what I always trying to explain earlier, right? So Flume's transfer and forget. If you notice in the first slide, right? Once it left one Flume agent was acknowledged by the next, that transaction is committed. So if you lose data now, it's lost. Whereas in Kafka, if you notice, all it did is it adjusted its index to where in the top. So if something bad happens downstream, and we have shot ourselves in the foot where we've accidentally deleted production data, right? All we're doing is we moved our Camus index back. And the data warehousing team is laughing at me because I accidentally deleted some 10 minutes before heading over here. Which is our whole warehouse. It's nothing important. Trash was in the that's all I can say. Anyway, what we have right now, right, when the compressor agents send the data on and they delete it right away, these Flume compressor servers have 6 terabytes of disk space on them, and that's really there, so should there be some downtime, we need a place to back the data up, to queue up, so that it's not sitting on our ad server, right? And typically we have about 100 gig in use, right? So we have 6 terabytes out of 100 being used, and the rest of it's for emergency purposes. All right. What's really nice about Flume, though, right, is you can do things in flight. You can intercept data and manipulate it, right? And you can do conditional routing. There's a lot of selectors to do conditional routing that exist. We deemed it worthwhile to customize some. All right. So Kafka, pros and questions, right? I mean, the biggest pro here, one of the obvious pros here, right? It's one copy, multiple consumers. And this is really plays in really nice. If you have an issue where you're trying to troubleshoot something, you can pull your data off of production into a dev cluster and look at it. When you're doing cluster migration, right? You can pull in parallel. You can run the same Camus job pulling from your production cluster to your next-gen production cluster, right? And do diffs and compare all the output, make sure everything's working. It's a buffer temporal log, so it's transfer and remember, right? So now, like when I shoot myself in the foot and delete data, right, I can just roll back my pointer in Camus and say, re-pull it, I did it again. All right. But here's the question, right? Can Kafka, or in this case Kafka streams, which is the topic of our first meetup, right? Can we use that to replicate the logic we're doing in Flume interceptors and selectors? And if so, how expensive is it to do, right? Do we need more hardware? Do we need to, do I just need to assign it to engineers other than me? That, I believe we can, but I can't speak to that. I haven't had a chance, none of us have to roll up and mess around with Kafka streams. I know, Patrick, who did the initial, I think he's got arguably a better use case for evaluating Kafka streams than I do right now. So miscellaneous, Kafka benefits, some of this, right? It's cheaper for bifurcation, it's great for troubleshooting in dev or QA. The provider interface is very extensible, right? You can have it out of the box, write Avro stuff. You can have, if you want to do a Parquet implementation, write it. We wrote an ORC one. This is one that I really need to sell because I think there's a big engineering opportunity. We can really add some value, but there's no business requirement. This is a gateway to streaming for us. I think, that's kind of like the next level that we want to go to is do some streaming aggregations. And the fact that it flips, Flume's a push process, and when it can't push anymore, it backs up and it doesn't necessarily behave very well, right? When you go to Kafka, it flips it to a pull process where Camus is pulling the data. It decouples you from your cluster, which is really nice if you want to do cluster maintenance, right? Or you can take your cluster down, everything's just sitting in your buffer in Kafka, your cluster comes back up, you run a Camus job, your pointer's there, it pulls it all. Flume, we did a huge cluster upgrade before introducing Kafka. Flume worked great. It backed up in the file channel, cluster was up, we got the Flume agent syncing again, and everything drained. That was when we had a dedicated cluster. It does seem, empirically speaking, like Kafka running a MapReduce to pull the data out is a lot faster than a Flume channel drain. Okay. All right. Other little customizations we made of note. The enterprise data store, right? Data is pulled, by MapReduce, partitions in high partitioning in HDFS, right? We also do row-level transformations, right? So there was some data that was being done in a Greenplum MPP database to massage it more into their, what we did is we pushed that all upstream. So while we're pulling it off of Kafka, we're making it into its final representation that will be both in HDFS as well as in their MPP database. And in this, we really built, and this a lot of credit goes to Sean here, a near real-time hybrid data warehouse of Greenplum and HDFS. And so when users of the MPP database are querying data, it could exist fully in Greenplum, and it gets from ORC into Greenplum by a customized Greenplum ORC reader written by Sudhir here. That basically Greenplum, it reads the ORC file in HDFS, goes into Greenplum, right? Sean has further extended that, right, so that you can have the data fully in Greenplum, you read it all, now there's a whole copy in Greenplum, or it can be partially in Greenplum. So some of our bigger data sets, the day -2, or today, yesterday, and the day before, physically exist in Greenplum because that's what users look at the most often, right? And if you want to look at data older than 2 days old, it is now Greenplum seamlessly going to look on HDFS to find the data. yes, you have a performance hit there, but you've also just taken a huge load, disk space load off of your MPD cluster, which is a little more expensive than a Hadoop cluster. All right, so this is kind of one that kind of came up for the moment. We have another MPP database by Extreme Data. It's like an ETL MPP database, and there's a head node and all the data nodes, and the way we currently get data off of it, everything has to come off the data nodes to the head nodes. There's an inherent bottleneck there. And in order to, as that's grown, it's gotten basically unacceptable performance, right? So what we did is we implemented something at the data node or the segment level within the MPP database that it's parallel pushing that segment's data into Kafka, right? And this increased our parallelization. Instead of 1, we're going 16x increased parallelization, right? And when we're doing this, right, we also customized the Camus version for this that now takes that data and it takes it from the TSV data being published out of our MPP database into an OR file. So now we have the ability to go from TSV to ORC or from AVR to ORC. And our data warehouse, our enterprise data store, all of our data is persisted in a column form. All right, so what's next? Expansion, that's growth, right? We're adding more servers. In doing so, we're also going to upgrade Kafka. We're currently at 8.2. Now we have a support contract with Cloud Era Manager, so our Kafka and Flume will be through Cloud Era Manager instead of through Apache. It'll be the Cloud Era Managed, Cloud Era's distribution. All right, so then, next year, what do we want to get on here? Spark streaming, right? We'll get faster insight into data. We can do faster monitoring on data trends. Making sure that we're not timing out everything. What this will allow us to do is, if we're taking right now, we have Camus jobs running either on a 5-minute interval, a 10-minute interval, or an hourly interval, and that's based on the business's demand to see aggregate data. But when you run data on a 5-minute interval, you're producing 12 sets of files per hour, right? And eventually all those files are going to overwhelm your name node. If you're running it on an hourly version, you've got 1 set, right? So the idea here is when we go to a Spark streaming architecture, that is only going to be for aggregate, under hour type of data delivery. And we would do an hourly Camus job, cut down our number of data files, right? And it'll make life easier on our name node. And you're still having pretty darn close to, within the hour delivery of data in your data warehouse, your Hive data warehouse, so to speak. All right, so the next area is, can we get rid of Flume, right? Can we go, instead of doing Flume between our remote data centers and our Chicago data center, can we go Kafka to Kafka and mirror the topics, right? There's a few potential advantages here. One is, obviously, you simplify your topology, right? You've got one service running on everything, right? Right now, if you look at it, we have Flume running on our remote data centers, Flume and Kafka in our Chicago data center. Everything will go down to just Kafka. But if you noticed in my Flume simplified and Kafka simplified, Kafka does not have a notion of, it's a producer and a consumer of data on, basically like a write-ahead log type thing, right? So they have a product called Mirror Maker, which basically will mirror this topics down to here, right? So we still have to evaluate this out and see how it works, but we could set a TTL where I told you we're using about 100 gig in the remote data center on each server. Well, if we can set a TTL up here, on critical data, we could set a TTL of 2 weeks, right? And on the less critical data, we can set it at 24 hours, 48 hours, whatever. Now, should there be a catastrophic failure in our data center down here, right? This mirroring of topics works just like Camus. It is just it has a consumer reading from here with a producer writing to here, and Mirror Maker is keeping track of what offset you're on. So if we had a catastrophic failure, we would take the offset from where it had last gone, set it all the way back to the beginning of the topics, re-pull everything. We've just rehydrated whatever data we had stored up here in our Chicago data center. I feel better we're using some of that disk space, and there'd be a level of DR that I think the company would be happier with. The potential risk here is, we lose Flume. We have a certain amount of logic built into interceptors and selectors and stuff right now that we have to reinvent. And then once we mirror topics, right, there's a use case right now where our ad servers would actually want to replay some of this data on an event of like a crash restart. Right? So we could actually, if we have all the data sitting at this layer, it could replay data, resync itself for the standpoint of budgeting and pacing, right? So how to get started? I did a presentation at Big Data TechCon, right, where I tried to kind of make it a walkthrough in your IDE, where what you do is you'll set up a spooling agent to start your Flume flow to read text files and send them in, and I've got the instructions for setting up your IDE so you can run your Flume agent, step through with the debugger in there, puts to a Kafka, you use a Kafka source, Kafka sync, and a Kafka channel in there. How to debug the Camus jobs and some examples of changing Camus. This is kind of my personally, I find I'm much faster if I can like get an IDE, look at the unit test, step through them, and step through the code. It's kind of like the one it was for this, and the other thing that for this big data TechCon presentation. One, it's another thing when you get like a new hire or a college kid to say, hey, go through my Hello World tutorial, get yourself started. You get up in the IDE and you know what's going on. That's it. How long did that take? 41 minutes, not too bad. Any questions? Yeah?
So you said like some of your next steps you might be doing like the Spark streaming for aggregations.
Yeah.
The Kafka streams potentially does some of that. Have you looked into that, or is that a potential?
Well, with a dangerous 30 minutes of reading, right? From a standpoint of most people, if you go to a Fling meetup or like a Storm meeting or meetup or whatever, they're talking about, well, Spark streaming is really microbatch, it's not really streaming, right? From an aggregate perspective, and put the disclaimer in there, I don't have a whole lot of background in this yet, is that microbatch is I think what we want, right? Now, from a streaming perspective, that to me, when Jay presented at the first meetup, I was thinking, wow, maybe this would really help enable us because we could with streams reproduce what we're doing with interceptors and selectors, right? And now we're not, we're basically putting data down to the end exactly as we do with Flume, right? We have to, there's a learning curve there, right? But I think everyone who's here is kind of ambitious to learn, so these are all opportunities that'll unfortunately get delayed significantly by business requirements, right? All right. Anything else? All right. So let's see. You guys, thanks everyone for coming. Yeah.
You said you were batching the Avro messages into a bundle and like sending it to the hardware replication. But as I somewhere in Kafka documentation, the Kafka messages they don't prefer like real long messages. They prefer small messages. So is there a benchmarking you did that you came up with?
They do default to like a 64 meg or something like that.
Yeah, and the default's pretty big.
It's pretty big,
It's huge.
but you're going to get way more throughput if you do that. If you end up going one block per message, it's going to crawl.
So I think
you just got to find that sweet spot.
I think Jayish had stepped out. But Jayish, a couple months ago was at PatssyCon in Vancouver, and he had LinkedIn and some other people that are in the Kafka world a little bit larger scale than we are. And when Jayish came back, the one thing he said was that it's very impressive stuff. And he goes, the one thing that we actually stood out was the volume that we put through with modest hardware comparatively, right? And I was like, it was nice to hear, right? Because there's some trade-offs to it, right? When you have one per object, there's a lot of people are open sourcing stuff, expecting each Kafka message has one object payload in there, right? And once you bundle them, you're losing access to that. Whether or not you need to, that's your business case. The reason I mentioned is that, hey, maybe you run up to where you're having a hard time and you want to keep your critical data one so that you can use all that open source stuff, right? But if you got something that's less important and it's going to save you thousands of dollars in hardware, maybe you want to bundle it up. It worked for us. Everyone's got their own use case,
So what I derived from what you said is that the handling of that request is just pretty costly. So by bundling it, it cuts down on the cost. So the cost is not up by the size, it's by the handling of the thing.
Yeah,
Message.
the Flume documentation really, they say, oh, well, if you want to get more performance, right, set your batch size larger. And the problem with that is if your batch times out, they send the whole batch, you get that many more duplicates, right? And no doubt, when playing with batch size, we definitely got a performance increase. It just was not meeting what we needed, right? And we looked at it and said, wow, we got a big hardware investment to do that. At the time, Steve here was my boss, and we're like, oh, well, what happens if we try putting extra, more than one in an event? And we put it in, we put 2 in, it was like, no, put 10 in. It scaled literally linearly. We saw, 10 million bundled as 10 take the exact same time within a few milliseconds to send end to end from West Coast and East Coast to Chicago, right? Took the same time within milliseconds as sending 1 million one at a time. Like, all right, yes, it seems like there's a huge cost just in the number of Flume events. And now I did a lot of messing around on the Flume side with that and convinced myself that Flume event was the cost far more than the batch size, right? With Kafka, well, let's just say we were under a timeline, right, to get to this enterprise data warehouse, right? And we were failing miserably. We were losing data, corrupting data, right? Patrick had good experience with Kafka and Storm and his team. And I had mentioned that, hey, Flume 1.6 is supposed to come out any minute that has Kafka support in it. And Patrick made the call and said, we need to invest in that right now because we don't have another plan. And hopefully by the time we've investigated it, Flume 1.6 is live. And the business came back and said, do 4 weeks. I'm like, oh yeah, we're gonna learn how to use Kafka with Flume, and we're gonna get integrated and live in 4 weeks, and it took 6. I personally, the comments I made behind management's voice, but they said we have 4 weeks. We're like, oh, give me some of your drugs, right? I mean, I knew that was unrealistic. The integration went phenomenally well. The only real setback we had here, we had a little bit of learning on the Camus, understanding what some of the properties meant, but not too bad there. And then my instinct to say, hey, let's unmarshal these from data files into individual objects, and then, oh, that didn't work, reverse that. But overall, the introduction of Kafka has, it went incredibly smooth, incredibly quick, and we've reaped so many rewards from it. And overall, Kafka's been incredibly stable. Our sponsor, Confluent, the reason this whole thing started was they called basically talking about, hey, would you like to get support on your Kafka? And they have to mention as a side note, hey, there's no meetup. Are you guys interested in starting one? We'll be sponsors, right? And as I'm talking to them, I'm saying, meetup, that sounds good. I go, think about paying for support. Unfortunately, I think we have to have a catastrophic failure before that's going to happen. And so far, your product's been too stable. You're trying to sell us on something we haven't had, to buy support on something we haven't had a problem with. Write some bugs, do something.
They are going to watch this video, Mike.
Huh? The thing is right now we have, we've got copies of data, and if we have a problem with Kafka, because we do keep stuff locally on our ad servers and stuff for a short period of time, God, I pray it doesn't happen, but yes, we could rebuild ourselves if we had to. It's just, it wouldn't be pretty, right? One of the reasons I'd like to go to the Kafka replication is that, hey, we're taking that 6 terabyte per server, and we've got, like in a remote data center, like 115 servers or something scattered across them, 6 terabytes each. That's a lot of DR sitting out there that we're using on average 100 gig out of 6 terabytes in each one. It's nothing, we'll see. I myself, if I got to pick my priority queue, right, I'd be saying, well, let's get the Kafka replication and let's get the Spark streaming done, because that's where my interest is, right? So I'm pushing for that. I'm not sure where I think Andy, is Andy your boss?
Yeah.
Typically, so Patrick's boss came up to me with the hey, he's got a use case to have the mirroring done, and he could actually leverage a topic of aggregated, stream aggregated data, right? And I'm going, really? Tell me more, because I want to get it in front of my boss so that it starts, getting some traction and credibility that, hey, we don't just need this for the sake of engineering. We need it because it's a business win, right? If we can make a business win out of it, then we get to learn new stuff, and that's. And I think everyone who's here is here because they like to learn and extend their knowledge. So I look forward to the opportunity.
All right, thanks for coming out, guys. Thanks, Mike.